You guys hear me?
Roger, Roger.
All right. So today we're going to be reviewing client-side virtualization. Client-side virtualization is a common system in which operating system is managed on a local server and executed to a variety of local client devices. In this session, we're going to learn the purpose of client-side virtualizations, the requirements and steps needed to set up client virtualizations, and the ways to avoid the common pitfalls overall. By the end of this session, we're going to learn how to define client-side virtualization, describe its overall purpose, list the requirements needed to set up and use it, and be able to describe how to use client-side virtualization. And then obviously, lastly, to be able to identify the common pitfalls themselves, be with security concerns and or the actual configurations when you're setting up the virtual machines. Virtualization is the technology that makes cloud currently possible. Cloud computing without virtualization is nothing, obviously, because client-side virtualization happens on the actual client machine itself. The client-side desktop virtualization is done by creating multiple virtual machines on a physical machine. No longer now, which is called a hypervisor, do you need a whole bunch of servers. If you have a good enough server which has enough processing power, enough RAM, and enough hard drive space, you can make yourself a server farm inside these different types of servers. There is two types of virtualization. There is a type 1 virtualization servers, and you have your type 2 hypervisors. Both are hypervisors. Your type 1, we will get into details, is basically that. The lowest level is where the hardware itself has no operating system per se, like Linux or the Mac OS or Windows running. It is himself all inclusive. This unit is a type 1 hypervisor. From here, now you can create a plethora of virtual machines, be that you need for a Linux, you need a firewall, you need to create yourself a server in Windows, whatever it is you need. This type 1 hypervisor allows you to create all virtual machines from the actual hypervisor itself. Versus the type 2 hypervisor is usually when you have an actual OS, or it is when you have the OS installed on top of it. So you would have Microsoft Windows, and then on top of that, you would install another software. Usually, you have the virtual box that's available from you from Oracle, and I forgot what's Windows horrible hypervisor, but they do have their own virtual machine that you can actually use. Fair warning: all machines must have certain stuff that allows you. Can anybody remember from our processors, what type of processor would I require to be able to create virtualization?
Multi-core.
Multi-core, multi-thread.
Okay, and there's one more thing
Hypertext.
it needs to have one more thing. We're almost there. Multi-core, but it has to have virtualization capabilities. If it doesn't have virtualization capabilities, and neither does your motherboard, you just basically are going to crash. We've had instances where even the motherboard and the processor is capable, but what could be now the problem? I just told you it is able to do it, but currently, for some weird reason, it does not want to work. What could be a setting or something that we might have not done correctly? I'll give you that much of a hint.
Setting in the BIOS.
That is correct. We also have to wake it up on the BIOS and let it know, hey, by the way, you're going to be using the virtual world real quick. So I need you to make sure you understand that they're going to start talking to you in virtual language. So therefore, without turning that on, you will be obviously again with the same problem. So all these are things that we're going to be concentrating and holding down into inside this specific presentation. Any questions or doubts so far? So, how would you explain virtualization to a client? Can somebody tell me?
Being able to use a different operating system than the one that you have installed natively.
Okay, but couldn't I just install a second partition with another OS?
Yeah, you could, but I think the key would be that in that case they cannot run at the same time, and if you have virtualization, you can have as many as you want, basically at the same time, different things. If your computer is allowing
Okay,
the resources.
that's another reason. That's true. It allows you to actually use all the resources and share them on the different things. Well, compared to, as you stated, now if I have a dual boot, it could either only boot that OS or the other. In the actual virtualization world, we need to understand that, as we see here, the hardware itself, when it is a type 2 hypervisor, has the OS installed. And on top of here, then you have your actual apps and or your containers. While here in the virtualized world, you have your virtual hypervisor virtualizing, and then you have your virtual containers, each one with its different apps. This is a normal operating system, right, with all the little apps. But now I can go and create a virtualization layer and create a computer who has app A and app B, another computer which has app C and app D. This is one of the things that it facilitates. And at the same time, it could be maybe that these app C and B maybe conflict with each other when they're installed on one physical machine, but the user himself does require both of them. So this is another workaround. And at the same time, there is times that there is sunset operating systems. Windows XP is one real good one where a lot of the programs have not been upgraded. Therefore, a virtual machine is a must, since the old operating system is not going to be running in a new domain of a Windows 10 environment. You would need a virtual machine to allow you to install that old system who has not been sunset and or upgraded to the newer version. This would allow you to facilitate the process and to be able to use different virtual machines at one time. At the same time, there is servers that facilitate the process just like this, so that instead of you having to install all these applications, you could actually just run it on the client side. Questions, doubts? So one of the great things that we have in here is the sandbox feature. Does anyone know what the sandbox feature is?
It's like
Like,
something that separates it out, closes it off from other things.
Yes, this is one great thing that we have also within the virtual machines. You could just imagine that if I am working on a code itself and I am upgrading an application like I just stated, instead of putting it into the real world, I could actually install it into this virtual machine and test it. I can create a test server and I can create a test actual machine who will mimic this environment in a sandbox. It will not go out into the real world. It'll only stay in its area. Likewise, I can actually create a sandbox where I disconnect completely the network card, where it won't talk to anyone at all. That way, if I want to go and test the latest and greatest antivirus code, because supposedly it has taken care of that day one virus that just came out, I, as a coder that is developing for that antivirus, I can go and install that virus in that virtual sandbox, update it, obviously, hopefully before I did that, my antivirus, to see if the code works, therefore successfully not getting a virus into the real world. It will be self-contained into this virtual environment. If something happens to the operating systems, it's dead, I can care less, but my actual computer would actually not die. This helps out in a lot of these features because of the fact that obviously some users in some of these environments, especially in the large call centers, were having issues with their PCs, be it with viruses or anything else. It was an easy fix where they could actually just kill that virtual machine and bring another one right back up. Any questions, doubts?
That's what some companies use to like train new hires or without using like their live system and stuff like that, right?
Currently, AWS is one of the greatest ones that are out there and selling these things. There is other people who are selling some cloud computing versions where basically you will install a PC out in AWS in the cloud environment, and the user logs into AWS, and it looks like if they're inside their own desktop. This would allow them to now, especially now that a lot of people are working remote, to be able to now use all of the company's data servers, all of the company's systems without the risk, as long as a user doesn't go and do something else, without the risk of the transmission one being seen, because if you're using Teams or Outlook or anything, it's going to be encrypted inside that virtual world. So the actual encapsulation of that communication is going to be encrypted, versus that if you would just configure it in your computer at home, Outlook, to go and send an email, somebody can actually capture that information and sniff the information. The same thing if you're going onto the browser and you're trying to use the company's websites. If it is HTTP, they will be able to see that. Versus inside this Amazon workspace, you will not be able to see any of that encrypted traffic. Any questions or doubts on the benefits and or the uses of it? So what is it that makes this possible? It's the actual hypervisor. Kevin, can you help me out here?
Yeah, the hypervisor. The key enabler for virtualization is a piece of software called the hypervisor, also known as Virtual Machine Manager, VMM. The hypervisor software allows multiple operating systems to share the same host. It also manages the physical resource allocation of the VMSs. There are two types of hypervisors, type 1 and type 2.
Thank you. Definitely, there is, as we stated, type 1 and type 2 itself. The virtual machine hypervisor, the difference is one is the actual hardware one, while the type 2 would be, or layer 2, you could say level 2, is where we're talking about the OS is now controlling the hypervisor. That you could see on my machine itself. You can install, or your machine, you can install the Oracle VirtualBox versus buying actual server whose job is only to create virtual machines. Questions or doubts on a type 1 or a type 2?
I'm sorry, yes. You said type 1 was hardware and type 2, the OS controls it?
That is correct. It is the hardware is here, right? Then you put Windows or Linux or whatever, Mac OS, whatever OS you want. Then on top of that OS is where you would install the hypervisor software. That is a type 2 because the operating system is controlling the actual hypervisor. A type 1 is where you have your hardware, and then that hardware has a hypervisor software OS installed on it. There is no Windows, there is no Mac OS, there is no Linux, nothing except for this hypervisor. A lot of the times it has a GUI interface to allow you to create the virtual machines, as we will see in any other hypervisor, where it asks you if you're going to be creating a Linux, a Mac OS, if you're creating 32-bit, 64-bit, how much memory do you want to allocate, what type, how many cores of CPU, all that. We will get into the details. All that is in the type 1. There is no booting, no risk from the actual operating system itself from you being able to get into these virtual machines. There is a higher risk if you understand, if there's a backdoor to a Windows operating system and now you install that hypervisor on top of that, this host machine, whatever it has as a weakness, is the weakness to all of its virtual machines. Though the other way around, the virtual machines, you could make them where they can't come out, but you still, if you're on a type 2 hypervisor, you have the weakness of the original S, whatever the host is hosting. Versus, and the one that is a type 1, this is very expensive, usually is a server-based one, is one that would be dedicated only to create virtual machines. much more secure. And again, the only thing there is the majority of the times people do not write per se viruses for a type 1 hypervisor. They would be writing something to the masses, to a Windows OS. And lately they've been getting bored. They're going after Apple also. Questions, doubts?
So is it becoming more popular, or is it more popular just that we kind of don't know it in the mass public of people buying this rather than a laptop with?
Type 1 hypervisor would be a dedicated server. This would be for a company who wants to create a whole bunch of virtual machines. Example, Amazon Workspace. They would have a type 1 hypervisor. They're a dedicated machine that creates a whole bunch of virtual appliances and machines. Because we're going to learn that there's not only PCs, you can create switches, routers, you can create anything in the virtual world. Firewall, anything that's in the real world can be created in the actual virtual world. Any questions between type 1 and type 2? All right, and we are a little bit more into details of the definition. If you can help me out here, Benjamin. Benjamin, wake up.
Sorry, muted. Type 1 and type 2?
Please.
All right. Hypervisor types. Type 1, known as bare metal or native, works directly on hardware of the host and can monitor OSs that run above the hypervisor. It is basically the OS for the physical machine. Purpose, sharing, managing hardware resources between different OSs. Type 1 is faster and more secure than a Type 2. Examples, MS Hyper-V and Citrix Zen Server. And then Type 2, also known as a client-side virtualization. The hypervisor software is installed on an OS and then supports other OSs above it. Hosted hypervisor is independent on the host OS for its functions. The OS that runs within a VM is called a guest OS. Purpose, uses include testing applications used by developers and as honeypots to lure hackers. Examples, VMware Workstation and Oracle VirtualBox.
Thank you. Yeah, there goes the name VMware there. And as for the example, as they see, they have a Microsoft hypervisor itself, or Hyper-V, sorry. And then you have the server of the Citrix Zen servers, which dedicate themselves to that. As you can see, these bare metal or native ones are much more secure than the ones that are in the type 2. Since, once again, you are as good as your weakest link. And in this purpose, since the actual host, which is the computer, is weaknesses, and whatever antivirus or anti-malware that you have is his line of defense. Therefore, whatever is written to hack this OS is your vulnerability at that point. Compared to a bare metal, usually I'm not aware of anyone that bored writing towards those servers. They're more locked down. Questions, doubts? All right, here goes now a little more of a picture representation. As we see here on the bottom, we have blue representing the actual physical hardware. Then you have your actual hypervisor actual there. And then on top of that, you can put whatever guest OS you'd like. Versus inside those, on the other side, you have your actual hardware. Then you actually operating system of the host. See, because now the host itself has an operating system. Then now you can install the actual hypervisor and create the guest OSs and install whatever applications. Once again, there goes that extra layer of weakness here, which is that host OS in the middle. Questions or doubts? Okay. Next one here, Fadil.
Client-side virtualization requirements. Running multiple operating systems on one physical workstation will require more resources than running a single operating system. For performance reasons, the workstation used for virtualization should be well equipped, specifically in type 2, which divide resources between the host operating system and its virtual machine operating system. The primary resources are CPU, RAM, hard drive space, and network performance.
Definitely, we need to take into account every single operating system that we're in there. Why would I have to take into account every single operating system that I'm going to be putting, be that it is a type 1 or type 2? Specifically, also on a type 2, it makes it even harder because we got another OS in there. But bottom line, either or, you still need to look at this. Why would I need to look at the specifications of the CPU, RAM, and hard drive space when I'm creating virtualization?
Because it's shared between the resources are shared between both of the OSs.
Exactly. As we stated before, if I create partitions and install an OS on every single partition, it will utilize all of the resources necessary. There is minimum requirements for every single OS installation. Therefore, hence why we needed a multi-core processor, multi-threading, whatever you want to call that, and one that's able to do virtualization. Because of the fact that we need to be able to allocate resources to every single virtual machine so that it can be able to run. Every single OS has a minimum hard drive space it needs. Every single OS has a minimum RAM. Every single OS has a minimum CPU. Every single OS, believe it or not, also has a minimum of its video. Therefore, if we do not take into actual account those resources when we try to turn on all these virtual machines at one time, it will most likely crash if we don't have sufficient. Questions, doubts? Next one. Josh.
All right, requirements, hardware resources, CPU. A multi-core processor is recommended since the hypervisor can treat each core of a processor as a separate virtual processor, and it can even create multiple virtual processors out of a single core. Some hypervisors require the CPU to be specifically designed to support virtualization, Intel VT or AMD V. In most cases, it must be enabled in the BIOS before the hypervisor will install. Memory is always the major concern with using virtualized instances. The hypervisor allocates the existing RAM between the host OS and each VM. However, each OS installed needs to have at least the minimum RAM required in order to run the VM. If the host OS requires 4 gigabytes of RAM and the guest OS requires 2 gigabytes of RAM, then you would need a minimum of 6 gigabytes of RAM. Recommendations for installing a hypervisor and VMs include a hardware-assisted virtualization and 15 gigabytes of free storage space for each instance.
Thank you. So what could be, let's say if I did install into this computer, so we could play with around here. So it says in the example here of memory, let's say I did put the 6 gigs minimum of RAM into this computer. What could be impeding me when I did this in a type 2 hypervisor? In other words, that'll be a big clue. Why is it that I could only see 4 gigs and I can't allocate all 6 gigs? I installed 6 gigs to the computer. I'm using a type 2 hypervisor. So I have an OS and I'm going to install hypervisor on top. I'm installing the virtual machines and I want to allocate all 6 gigs, but I could only allocate 4 gigs.
The other thing is the other OS is using 2 of them. Maybe.
Well, I have this. I have the recommended 4 gigs and 2 gigs. So I have all 6 gigs physically installed. My BIOS saw it, but for some weird reason, when I'm going into this OS, it only seems to see the lesser amount.
Is it because that's what it was allocated and it's self-contained and it just doesn't see anything else?
The OS is only seeing 4. So what OS would only see 4 gigs of RAM?
The host one.
Okay, and what type of OS is that? What type of bit? I'll give you that much of another clue. What type of bit of OS is that? Is that a 32-bit or is that a 64-bit operating system?
64.
32.
I think
Ooh.
64.
Okay.
You said 2
Got it.
gigabytes of RAM?
I could only see 4 gigabytes of RAM on this OS. I installed 6. My BIOS is able to see 6, but for some
Oh,
weird reason,
64 bit.
he's only able to see 4 gigs of RAM.
Okay, yeah, I guess it's 32 then.
That is correct. It would have to be 32 because we learned that if we get the little 2 and we put the little caret sign with 32 next to it, it'll tell us that it's 4 gigs, 4.2. So the 4 gigs is the maximum that a 32-bit operating system will be able to see. So be very careful when you're using these actual OSs and when you're installing virtual machines. What's the capability of the host OS? You're again only as good as the weakest link. I've seen people who go install a virtual 64-bit operating system on a 32-bit system and think that they're going to be able to actually get all of the RAM, and they can't. It's not going to see it because the host OS isn't able to see it. Well, that was the ice cream truck. Let me pause here, please, the recording. I'll see you guys at 07. So, as we stated just a minute ago, in reference to the memory itself, we need to be careful in what the actual host, especially when we're dealing with type 2 hypervisor, because the actual host OS it itself may not be able to. Another issue that we need to look at, as we stated before, is although the actual motherboard is capable, we need to make sure it is enabled within the actual BIOS. As you can see here, this is the old BIOS. The UEFI BIOS has a little bit different feel of it. We know that is a graphical user interface compared to that old one there, but it's the same instance. We need to go into the BIOS to UEFI and actually enable virtualization. Requirements of each VM instance overall is to have its own IP address to its own little virtual world. Your actual, if you do not leave it in a actual sandbox and you want it to go out to the real world, you can decide within the actual hypervisor if you want to choose, is it going to be in a private LAN itself, in other words in this little sandbox LAN, with using your physical NIC as a router per se to NAT your information, or you could actually choose that it's IP, it's in the real world. So it'll actually get an IP from the actual network that the host is in. Your choice on which way you want to do it. Obviously, depending on what it is that you're doing, be very careful, because if it is that you're doing testing things and in a testing environment, it's strongly recommended that you do that in a sandbox environment where it cannot obviously impact the actual operations. Questions or doubts? So on the actual, here's your NIC card, you could say, of your PC or the host. In here, as I stated before, you can actually create a virtual switch inside, or a virtual appliance inside this hypervisor. You turn it on, and now the switch is available to everything in that little virtual world. Requirements overall is that every single hypervisor has its own way to set up virtual switchers. Either create a virtual networks itself, as I said, or you could use just the actual physical NIC as you would say, getting your DHCP requests out to the real world. You could either bridge the networks, or you could actually create your own internal LAN. It's the two ways, depending on which way you want. Bridge mode, as we learned, is someone. Bridge mode would be
Connecting to separate networks.
two separate networks. And since it is dealing with the physical, in this case, it is from the physical to the virtual world. It's going to bridge those two networks. And in the layman's terms, or in the other machine that we were talking about, bridge would be maybe from copper to fiber. So you're still in the same subnet, you're still in the same IP LAN, versus that if you go and create it with its own internal network, and now you use that as your NIC card, your physical NIC card, as it natting for you. Now you have your own DHCP and your own actual subnet inside that virtual world. Questions, doubts? All security concerns that affect the individual computers obviously apply to the VMs themselves. As we stated, if the actual VMs, if you install XP on that and you put it onto so it can connect to the internet, fair warning. Not only obviously do we have the problem as it is with the host, because we're on a type 2 hypervisor, I myself, as a virtual machine, have my own flaws. Whatever this OS has as its flaws, whatever you need to put in there, be some type of anti malware or the latest and greatest patches to that OS, specifically if it's an OS that's no longer supported, you're going to be into that same vulnerabilities where hackers and or malware alike can actually infect you. Questions or doubts? Now, there is one more thing that we need to learn. And this puppy is almost the same as the other guys that we said. The variance between an emulator and a virtual machine is anyone? Someone?
This only
The
runs one type of
emulator.
program.
That is correct. An emulator can only emulate what he is. In other words, he could only act as what he was intended to act as. A virtual machine, I can install anything I like. I can, like I told you a minute ago, I can make him into a switch. I can make a hat. I can make a pterodactyl. I can make anything I like. On an emulator, if it is for instance, BlueStacks is an emulator. Anyone who's ever used BlueStacks, that is an Android emulator, which basically on a Windows environment, I can actually act like if I have an Android phone or an Android tablet and install everything off of Google Play Store without actually having an Android. It's emulating it on top of a Windows base. What comes is what I get, versus the actual hypervisor allows me to go in and create whatever machine I want, whatever I want to dedicate to this machine in a virtual environment, and install whatever OS or configure it however I want. If I want to connect it as a proxy, a DHCP server, if I want to make it into a switch, a router, whatever it is, firewall, whatever I want, I can create. An emulator could only emulate. Questions? Doubts? So, VDI, Virtual Desktop Infrastructure, refers to the process of running a user desktop inside a virtual machine that lives on a server, on a data center. As I stated before, that usually in the cloud-based one like AWS, I think Azure, I'm not sure what other one is out there. There is plenty of VDIs where then this centralized base server is creating the virtual environment for the whole company per se. There is some of them that have a hybrid. We'll get into that, what we call a hybrid, where it is public and it is private, and some of them are just completely private or completely public. Any questions on a VDI, which is a virtual desktop infrastructure? Now I no longer need to be at my computer to get to my computer. This facilitates that I can get into any computer in the world, and with whatever that API that I have to be able to get in through that door, be it AWS or maybe a website that I log on to, that allows me to get into this virtual environment without having to physically have that computer. Computers now have gone completely into the virtual world, like if they weren't there already, right? Questions, doubts?
Okay, how could we access those virtual machines through?
And an actual GUI interface, for instance, AWS itself has a thing that's called Amazon Workspace. Amazon Workspace itself allows you to be able to log on to a virtual machine. If you open this, it'll ask you then to go ahead and log on with your ID and password to that virtual machine. But I no longer work there, so there's no way I can actually log on there. Questions? Doubts? Oops, wrong one. Try this one more time. Yay, I think that's the right one. Any other questions or doubts on VDI, virtual desktop infrastructure? A lot of the times, as you can see here, in many cases, especially in these call centers, the big ones like for Cunard Cruise Lines, any of these big call centers that are out there, you'll be surprised how much of them are just thin clients on the actual user's desktop. They're not actual thick clients which only just connect to this virtual environment. Much cheaper. All the processing power is being handled off that server. Everything is inside that server, inside that virtual environment. No, hopefully, major risk of the PC not being up to date with the latest and greatest. And now I pass it off to my counterparts. If there are no other questions for me, I believe this is me.
All right. Just using your client-side virtualization is basically going to go with this, and doing a rough install on your computer. Which highly recommend you do in say by the end of the week. Try to get.
Oh yes, I know
Hey,
you
Kelly.
can't really hear you.
You got a little feedback, sir. I wonder, is anybody else? Everybody's muted, so.
Yeah, I wasn't really hearing him either. It was a lot of feedback.
Can you hear me better now?
Yeah, better than before.
Yeah, or I was getting a unstable connection warning on my computer as soon as I started. All right. Basically, what I was saying is probably by the end of the week, try to install Oracle VirtualBox onto your computer. We will be using it later in the cohort, but we're going to walk through right now, getting it put on there and starting to work on it. Depending on the operating, well, Diego's got it up on the screen now. But depending on the operating system you're going to want to install, you always want to make sure that you have those additional resources on hand in your computer already. Otherwise, it's not going to work. And the main things that Diego had mentioned before, your CPU, your RAM, your hard drive space, and then if you're actually going to operate it outside of a sandbox mode, a network connection. But you also want to, in an enterprise environment, it's going to be based on what your client needs or what you're wanting to test. But for the purposes of the cohort, we will be using bare minimum on operating systems and stuff like that. So it'll be a little bit easier to get your feet wet with it and start working with virtual machines. And using your hypervisor. Once you get it installed, it's pretty easy. Just make sure when you go to Oracle, pick the one that's correct for the operating system you have, be it Mac, Linux, or Microsoft. It's pretty straightforward download. Then you'll get the nice icon on your desktop, which will take you straight to your heads-up display. And you can create a new virtual machine. You can create as many as you want, depending on the resources you have available within your computer. And I believe we are going to be creating a Kali Linux one. Is that correct, Diego? So yeah, Kali Linux. We're going to be creating one of those, which your more powerful open source operating systems you could use. And thankfully it is free. So you would create a new virtual machine. You would just basically click on a machine, drop down, select new, move to the next one. You want to name it, and then select the type of machine you're going to put it on and the version of the operating system you will be utilizing. Diego, can you jump back to the slideshow, please, sir? Or unless you want to do it here, if you want to walk them through it here.
That was a mistake, sorry.
No problem. So yeah, you want to name your virtual machine, make sure it's one that will key your memory and let you know exactly which one you're working with. I mean, if you just name it Linux and you have like 10 different Linux ones and you're running different tests on different ones, it's going to be hard to pinpoint exactly which one you're doing it. So try to use a little bit of a detailed name when you're picking them. Then selecting the operating system you're going to be using. And I think on these, you can go all the way back to Windows 3.1, which is one of the first GUI operating systems you can work with, which is actually kind of cool. And then come all the way up to the modern systems you're using now. If you want to run a server on your computer, you can run like Windows Server 2016 on there and stuff like that and utilize those services as well.
Now, I'm sorry to interrupt you. Why would we need to be so picky about what we're selecting on that previous screen? if anyone knows. Why should we be so picky about what we're selecting here? Believe it or not, when you select what's here and you tell it what you're about to do, it will now know the minimum requirements of that actual operating system, and it will tell you in the next screens what it's expecting as its minimum. Therefore, that's why we should make sure that we select the type of operating system, and the version is very, very necessary. It has its own way of knowing what's required. So that's just an FYI.
Max, yes. And another wonderful thing, like say, I think we had talked about it earlier, things like XP and stuff like that. If you have older software, as they call it, legacy software, that only operates on certain older platforms, like XP is one of the biggest ones, you would use the hypervisor to go ahead and do that for you. That way you can actually update your machines, but still maintain the functionality of the older applications that you require. And here, they'll give you the baseline minimum requirements that you would need for your hypervisor that you're setting up. However, you may wish to allocate more resources to it depending on what you're doing. Because you want to plan for that. If you're testing a lot of software and how it's going to affect this particular operating system, like if you're using, Windows 10 and you want to see how it'll handle a new application that you developed, but that application you developed is 15 gigs of memory, and it's going to need X amount of RAM on top of what you're already going to need for the operating system. You need to make allocations for that. Any questions? Okay. That is.
Cool tunes.
All right. Yeah, I don't know who that was. Also, any additional things, USB ports, printers, anything else you wanted to have access to, you want to also make sure that you allocate the availability to the hypervisor to be able to get out. Because if you want it to be a complete sandbox, you're just testing internally, you do not want it to have access to the internet, all that fun stuff. You want to make sure that you set it up that way. You do not want to have external access, because that does still open up your machine to vulnerability. And if it's going to be accessing the internet, you need to make sure it's protected. So it needs to have, firewalls and stuff like that already in place. Or if you're going to be sending stuff out to printers and as stuff as well. Any other questions on this one? All right. Then finally, once everything is said and done, you will have your virtual machine and you'll be able to start it, and essentially powering it on. Once you power it on, it begins to utilize those resources like RAM and hard drive space and all that you have selected. But then essentially you'll be running a complete another operating system within a separated window on your computer. And you can test out whatever you want to test. If it's just you wanting to learn to use another operating system without reinstalling a new operating system on your computer, this is a wonderful way to do it. If you want to learn new stuff like Linux, if you want to get into learning how to use Mac OS, if you haven't used Mac OS, these are good ways that you can actually do them without having to set up different machines or setting up various boot orders on your own machine. Yeah, we just talked about this, starting it up, and it will direct you to install your and always when you're done, be sure to power it off before you close it down. That way you will free up your resources like RAM and stuff like that to be able to use on your main computer. Do not leave them running, otherwise it will just essentially chew up a ton of your resources that you may want to use for other things. Or if you're utilizing multiple virtual machines, you may be sharing some of the things like RAM especially. You may have, six gigs that are required, but you need 4 for another one, so you have to shut down one machine to be able to operate the other. So it's always important to shut them down when not in use. And with that, if there's any other questions about doing a quick install on a virtual machine, we will be doing more with it, because we will actually do a install in class for an actual operating system on a virtual machine. But to prepare for that, please try to, by the end of the week, get onto Google, look up Oracle Virtual Machine or VirtualBox VM, download it, just get it installed on your computer, just open it up, make sure it runs okay. And then you also may want to check and get to know the system requirements that you are working on as well. So if there's no other questions, I'll hand this over to Justin.
Thank you, Kelly. So basically, we're going to be looking at some of the common problems that you're going to see when dealing with virtual machines and virtual technology. One of the main ones is setting up the virtual environment. It's no different than actually doing a clean install of an OS on any Windows system or any computer system you're running on. It can have many different installation issues, just like the actual host. The simplest way to solve this is just follow the proper installation steps, reinstall if you need to, and it should just be able to work itself out after a while. Another one is just using the virtual technology, is that some system resources, it uses the same system resources as the host. So ensuring that your host has the adequate CPU, RAM, everything that it needs in order to run, as Kelly mentioned previously, you're able to actually run it smoothly and allocate the right amount of resources that the specific operating system requires, even if it's at the very minimum. Of course, one of the biggest ones is security concerns. You always want to make sure your permissions, firewalls, malware are all up to date, because whatever your host system has in terms of security, that's what your virtual machines will have also. So if there are potential holes, or your virus isn't up to date, that'll be a problem, and that can actually cause issues with the virtual machine as well. And then also, when you're working with viruses and testing out new stuff in the virtual machine, you want to make sure it is isolated and sandboxed. Otherwise, it can potentially leak out into the regular world, and yeah, that's where problems happen. Any questions on any of this? Okay. And I believe I pass this back to Diego.
Okay. Hello?
You're
Hello?
live.
All right, thank you. So we're going to be going into separate groups and basically trying to evaluate and determine your needs and ensure that you have for the CPU. So I guess I can set it up for you four. Give me 1 second. Who's in control? Somebody else is in control.
Last.
Oh, am I the host?
Let me see. I got it.
Yeah,
I think I got it. I just got it, I think.
Yeah.
All right.
You gotta make me co-host when you have a chance.
More than likely it is 64-bit, but we want to confirm that.
Overall, at this point, hopefully we were able to identify, if not know how to identify the actual hypervisor that we need to download. And if possible, as we stated, try to install the actual hypervisor so that we could be able to then install, we're going to be installing Windows 7 and Linux here for you guys to be able to play around with the actual operating systems for the 1002. That way you can mess up that virtual environment computer and hopefully not mess up your real computer. Any questions, doubts? Now we're going to quiz time. Which of the following are requirements and recommendations for installing a hypervisor and VMs? Choose all that apply. Anyone now? Anytime.
B and D.
B and D. Okay.
Maybe others too, but that's the ones I think for sure.
So you're saying B and D for every single virtual
Agree.
machine. For every single virtual machine, I need 2 gigabytes and 60 in gigabytes of memory and 15 gigabytes of hard drive.
Well, they
I
might
need.
actually need more than that technically, but
Okay,
I would think
so
that's
now you're changing
minimum.
your mind. So what out of here, what would you say then is a requirement? Because now you're changing the number on me. So is it or is it not? Will
A
every
and C.
single A and
And C virtual network driver.
okay, we're getting somewhere.
I would say A, C, and D.
I think all the above.
And now if I was creating a sandbox, would I need a virtual network driver?
And no, so yeah, A and D.
Okay, there we are. We just got to think out loud. Overall, as we stated, yes, it's going to be a virtual hard drive. Minimum space free is 15 gigabytes. It will grow. We need to make sure that when we create that VDI disk, that it is dynamic, that is not static. And another thing that we need to know is the actual hardware able to create a virtual environment. As for the minimum virtual memory, that all is depending on the actual guest OS and the actual OS if it is a type 2 to be able to determine what is the total memory that you require. Number 2, using a client-side virtualization, how many operating systems can be running on your computer at one time? Using client-side virtualization, how many operating systems can be
D.
running?
I think D.
D.
Somebody said
Yeah.
B. Okay.
D.
Somebody said B. Okay. Anyone else
D.
want to take a stab? Hmm?
D.
B as in boy?
D. D.
E as
D?
in
Delta.
dog.
Okay. Now this one is tricky. I'm not sure if we did cover it in any of the presentation, but that I am aware of, if it is client-side virtualization, so you're on an OS and running, my understanding is, unless if some part of my memory went whack, the most you could have running at a time is 3. I could be wrong. I may be crazy, but we'll give it a try. Now, as for the type 1 hypervisor, that does not have any limits except for the actual limitation of the hypervisor and the actual resources. But I believe that is one of the trick questions in reference to client side or a actual host OS using client virtualization. Next one, VMs running under a type 1 hypervisor are isolated from each other. True or false?
True.
True.
I would have to agree with you. As we stated at that point, there is no operating system per se that you can actually hack into to be able to get into those different virtual machines. They should, in essence, be standalone in that virtual environment, which is the typical use for a type 2 hypervisor. Choose
A
all
and
that
B.
apply.
A and B.
I would have to agree with you. That is correct. A and B should be what the most that we use for. As we stated, the actual VDI deployment, that would be more in the client of cloud computer, which is a virtual um, data infrastructure, and then you could have anything in there and part of the cloud computing yourself. Which of the following is true of a type 1 hypervisor? Which one?
C. Oh,
C.
yeah.
A and B. Oh.
This is a type 1, so it is bare metal. That is correct. Oh, maybe I got one wrong. Hey, look at that. 3. No, actually, it is unlimited. Look at that. I could have sworn it was 3. I do apologize. I'm going to have to go look that up now.
You
Ah, now you
arguing
get me
after
out.
all, Diego?
I told you, I'm never wrong. I'm just misinformed.
Sorry, Diego.
All right. Any other questions or doubts? Okay, let's stop it here.